Hello and welcome to the GitOps-Based deployment of OpenNebula control instances screencast. In this screencast, we are going to showcase how the OpenNebula Frontend node can be provisioned in a fully automated and user-friendly way. This is a fully automated deployment and it's user-friendly, meaning that no previous experience installing OpenNebula is required. It is fully integrated with Git. The deployment is getting kicked off using GitHub issues. State files such as Terraform, tfstate, and config files are getting stored inside the directory folder on the automation repository. It also uses the comment section of an issue to post the status and connection details. It relies on the industry standard toolsets such as Terraform and Ansible, meaning that it's easily expandable and modifiable should you need to. The architecture consists of two GitHub repositories. Automation repository that in the scope of this demonstration we are going to name OneHosted, and the repository with OneDeploy toolchain. OneDeploy is the automation toolchain that streamlines the deployment of OpenNebula, frontend, and hypervisor nodes. The GitHub functionality, GitHub Actions, and GitHub Runner are utilized to execute the automation. As a target for the frontend node, also known as the control plane, we are going to utilize an instance of the configured size provisioned at a defined public cloud provider. The process begins when a user has submitted an issue that contains a specified form. The form and values are going to be turned into the configuration file. Once an issue is submitted, GitHub Actions is getting triggered to validate the input. Once an input is validated, the user is getting notified via an email. In case of errors, the user must resolve them and revalidate by adding the specific label to an issue. In case of successful validation, the next step is to assign the action deploy label to an issue and kickstart the deployment. Using the GitHub Actions, the GitHub Runner based on the Ubuntu LTS image will be deployed to execute the code using the configuration file that was built during the validation. The automation repository contains a link to the specific commit inside the OneDeploy repository, thus it's not affected by the recent changes. The state file for Terraform as well as any other file are going to be stored in the directory inside the automation repository named after the issue's unique identifier. Once the front-end node is running, the user is going to receive yet another email that contains IPs, FQDNs, and credentials from the newly booted system. After this, the user can start provisioning clusters using the OpenNebula control plane. We are starting by creating an issue in the repository. You must input the following variables: name to name the environment, an email to receive the notification regarding the environment, the number of nodes to have from the get-go. 1E, should you run the Community Edition or the Enterprise Edition of OpenNebula? Valid until the date when to expire the environment. There are additional fine-tunings that you can apply if necessary, for example, the size of an instance for the control plane. However, in the scope of this demonstration, we are going to proceed with the bare minimum. Once the configuration file got validated, we are assigning the label to kickstart the deployment. The deployment has been successfully performed. There is a notification in our mailbox as well as the comment added in the comment section with the credentials. Now we can connect to the environment and validate that it works as expected. Should we don't need this environment anymore, we can start the destruction procedure by simply applying the label action destroy to an issue. By applying this label, a GitHub actions will trigger the destruction of an environment. There is also a dedicated directory inside the automation repository that contains all of the configuration and state files that were used to deploy this environment. Aside from the initial deployment and deletion, the following labels can trigger an action. Action validate in case the configuration must be revalidated. Action recover in case there is a mistake in the configuration file, the action recover label must be applied after fixing it. If any updates were made to apply those changes, the action update label must be applied then. Once you deleted the environment, any files no longer needed to be stored in the repository, the action purge label must be applied. After that, you can successfully close an issue. This screencast was developed in the scope of IPCEI-CIS project. Thank you for watching and see you in the next screencast.